Assalamualaikum and hello to Engineer Mazlan bin Ahmad Mansur. We are from 2 BMMA, section 2/1. Are going to present about torsional loading supervision from actual structure. For that, we are from BMMA, 2 BMMA, section 2/1 consists of me, Amsyah Koyum bin Batu Hisham. Next, followed by Muhammad Zulkarnain bin Madrus. And then followed by also Ahmad Abdullah bin Muhammad. So for the first section, we will show about the actual structure of our group title, which is scissor jet. Scissor jet is a conventional jet that is used in every vehicle on the roadside or used by people surrounding nowadays. The material of the scissor jet is usually made from steel and mild steel. So based on the poster also we can see the idealized model. The idealized model was drawn by using the salt system Katia V5. So as we can see, the drawing is likewise the actual structure of the product that we are going to describe on the calculation and question following it. Next, we move on to the second, which is about the free body diagram. As we can see, based on the free body diagram here, scissor jet will be inserted with a force about 10,000 Newton, for example. 10,000 Newton force is a force from a vehicle that is being lifted by using the scissor jet. So, based on the free body diagram also, we can see the distance between holes. For example, from above, we can see that on the top holes, there is 50 millimeter distance, and the width of the top is 70 millimeter. As we move on to the below, we can see that there is a long shaft that acts as the main part of the scissor jet to lift or to unlift the jet. It can be said also contract or expand the jet. You can see on the diagram also there will be a movement resulted at the diameter of 50 millimeter shaft that will be turned around clockwise to lift the car or turn around anti-clockwise to bring down the car or vehicle down. Then there are various amount of angle will be resulted. For example, in our group, we select 30 degrees on the degree, and there is also angle of 90 degrees involved when we are going to leave the car. Then move on to the downwards. There is the distance between holes, which is 30 millimeter, and the width for the base is 400 milliliter. So next we will move on to the calculation presented by Muhammad Zulkarnain bin Madrus.
Hello, hi. My name is Muhammad Zulkarnain. So now we discuss about the calculation. So from the FBD, we assume that the scissor jack are rotate 90 degree to the right to lift the car and it take about 5 seconds. So we use the formula V equal to D over dt. D over T. So for D, 2 pi r divided by 4. So we get 1.963 times 10 power of negative 2. So we use the D to get the value of V. So for velocity, we get 3.927 times 10 power of negative 3 meter per second. After that, we find the work force. For work force, the formula is force times D. So average human hand 460 gram or 0.46 kilogram. Acceleration in circular rotation equal to centripetal acceleration. So we must find the AC first. So the formula for AC, V square divided by R. So from the V we get previously, then 0.0039 power of 2 divided by 0.0125 and get 0.012 meter per second square. Then we put into the formula of work force, work force times D. Then the answer is 1.084 times 10 power of negative pi joule. So after that, we must find the torque first. So formula for torque is R multiplied by force multiplied by sin theta. So we get the answer 6.9 times 10 power of negative 6 Newton meter. Then for the length 2250 mm, and we convert to meter, 0.25 meter. So shear modulus, we use the material steel. So formula for shear modulus is E equal to E divide by 2 bracket 1 plus V. So the E 210 gigapascal and the Poisson ratio is 0.3. So we insert the value into the shear modulus formula and we get 80.76 times 10 power of 9 Pascal. So for after that, we find the shaft polar moment inertia. So the symbol is J and the formula is J equal to pi diameter power of 4 divided by 32. So we get the answer 3.835 times 10 power of negative 8. And then angle of twist. The formula is theta. Yeah. Then we insert the torque times L divide by shaft polar moment inertia times shear modulus, and we get the answer 5.618 times 10 power of negative 10 radian. In degree, we get 32.18. So yield stress, the formula is I times Y. So 0.5 times 250, we get 125 megapascal. Factor of safety 420 divided by 250 and we get 1.68. That's all.
And thanks for discussion. I am Ahmad Abdullah bin Muhammad. The discussion number 1 is everyday usage of the tool or structure can cause the structure to yield due to the structure always under pressure, thus causing the structure to yield. Next, excessive force from car weight also cause significant yield on the structure. This is because every structure has its own factor of safety based on their material. If the force exerted upon the structure is more than its factor of safety, can cause the structure to yield. Third, force from clashing between the material cause the structure to yield, such as mild steel and steel. The mild steel from the structure have lower yield strength. The steel will also suffer yield. That's all. Thank you.